Welcome back to the channel. Today we are exploring one of the most important tools in motion analysis, the velocity time graph. A velocity time graph gives us a visual representation of an object motion by showing how its velocity changes with time. The graph plots velocity on the y-axis and time on the x-axis. The slope on the graph represents the acceleration. A positive slope means the object is speeding up. That's positive acceleration. The flat horizontal line means zero acceleration. The object is moving with constant velocity. A negative slope means the object is slowing down. That's deceleration or retardation. The steeper the slope, the greater the acceleration. The shallower the slope, the less the acceleration. The area under the velocity time graph represents the total distance traveled. This can be calculated using simple geometric shapes like triangles, rectangles, and trapezium. Now let's apply all this to a real question. Question 1. A body starts from rest and accelerates at 3 meters per second square for 4 seconds. Its velocity remains constant at the maximum value so reached for 7 seconds, and it finally comes to rest with a uniform retardation after another 5 seconds. Draw the velocity time graph of the motion. Using the graph, calculate 1. The maximum speed attained during the motion, 2. Retardation in the last 5 seconds, 3. Total distance traveled. 4. The average velocity over the whole period. Okay, solution. Draw a vertical axis, y-axis for the velocity, and a horizontal axis, x-axis for time. Label the vertical axis as velocity in meter per second, and the horizontal axis as time in seconds. Begin both axes from 0. A body starts from rest and accelerates at 3 meters per second square. Draw a straight diagonal line beginning at the origin, because the body starts from rest. This acceleration is for 4 seconds. Write 4 here. Its velocity remains constant for 7 seconds. Draw a flat horizontal line like this. Add 7 to 4 is 11. Write 11 here. It finally comes to rest in 5 seconds. Draw a diagonal that slopes down like this. Add 5 to 11 is 16. 16 is written here. That's our velocity time graph. 1. Using the graph, we are asked to calculate the maximum speed attained. In this type of motion problem, the words speed and velocity can be used interchangeably. Using the formula for acceleration, A is equal to change in velocity over time. Since the velocity changes from an initial velocity u to a final velocity v, A is equal to v minus u over t. In this question, the initial velocity u is equal to 0 because the object starts from rest. So the formula becomes A is equal to v over t. This formula has 3 variables. Most of the time, the question gives us 2 of these variables, and our job is to calculate the third one. In this particular question, we are given acceleration a and the time t. That means we have to find the velocity, specifically the maximum speed v the object reaches. Back to the question. A is equal to v over t. V is equal to a times t. V is equal to 3 times 4, which is equal to 12 meters per second. Back to the graph. 12 is written here. 2. The retardation in the last 5 seconds. Retardation is negative acceleration. Using the same formula, retardation is equal to change in velocity over time, which is equal to v minus u over t. Here, the final velocity v is equal to 0. Initial velocity u is equal to 12. Because the body moves from here, the initial velocity, which is 12 meters per second, to here, final velocity, which is 0. Retardation is equal to 0 minus 12 over 5. Retardation is equal to minus 2.4 meters per second square. The negative sign shows it's a retardation or deceleration. 3. Total distance traveled. The area under the curve represents the total distance traveled. The geometric shape under this curve is a trapezium. The area of a trapezium is half a plus b in bracket h. A and b are the parallel sides of the trapezium, and h the height of the trapezium. Here, a is equal to 7, b equal to 16, and h equal to 12. Substituting, total distance travel is equal to half 7 plus 16 in brackets 12. Simplifying, 23 times 16. Total distance travel is equal to 138 meters. The distance can also be calculated by calculating the areas of each shape. The triangles, this one, triangle A, and this one, triangle C, and the rectangle B. Then add the values of the areas of the different sections. Using the formula, for triangle A is equal to half base times height, which is equal to half times 4 times 12 equal to 24 meters. For rectangle B, using the formula length times breadth is equal to 12 times 7 7 equal to 84 meters. For triangle C, equal to half base times height equal to half times 5 times 12 equal to 30 meters. Total distance traveled is equal to A plus B plus C equal to 24 plus 84 plus 30 equal to 138 meters. The unit is meters for distance. Final question. 4. The average speed. Average speed is equal to total distance traveled over total time equal to 138 divided by 16 equal to 8.625 meter per second, approximately equal to 8.6 meter per second. Question 2. The graph describes the motion of a body on a velocity time graph. A. Find the acceleration. B. What is the distance after 9.0 seconds? In this question, final velocity v is equal to 12 meter per second. Initial velocity u is equal to 2 meter per second. Time for this acceleration is equal to 4 seconds. Using the formula, acceleration A is equal to v minus u over t. Substituting, A is equal to 12 minus 2 over 4. A is equal to 10 over 4 equal to 2.5 meter per second square. B. The distance after 9.0 seconds. We don't have a single formula for this geometric shape. We will have to break the shape into 2 or 3. Let's break it into 2 and call this A and this B. A is a trapezium. Using the formula for a trapezium, total distance is equal to half A plus B in bracket H. Here, A is equal to 2, B is equal to 12, and H 4. Substituting, total distance for A is equal to half 2 plus 12 in bracket 4. Simplifying, 14 times 2 equal to 28 meters. B is a triangle. The formula for a triangle is half base times height. Shape B has base 5 and height H is equal to 12. Substituting, total distance for B is equal to half times 5 times 12 equal to 5 times 6 equal to 30 meters. Total distance travel will now be equal to A plus B, which is equal to 28 plus 30 equal to 58 meters. If you found this helpful, don't forget to like, share, and subscribe for more simple physics lesson. Bye.